organic synthesis and Arenes. Exercise, we did the first 5 questions. Starting with question 6. This question is about the carboxylic acid. A compound T contains element carbon, hydrogen, oxygen only. The T contains a carboxylic group and other functional group. A sample of a T which is a mass of 2.2 grams was burned completely to produce 3.3 grams of a carbon dioxide and 1.35 grams of carbon. In a mass spectrum, the compound T has a molecular ion peak of 90. Use all the data to calculate the molecular formula of compound T. You must show your working. First, from the mass, like 3.3 gram of a carbon dioxide is there. So first we'll find what is the mass of a carbon. As we know, the 12 grams is there in 44 grams. Like if we have 44 grams of a carbon dioxide, it will have 12 grams of carbon. So if we have 3.3 grams of carbon dioxide, how much carbon will be there? X. This will give us the amount of a carbon present. And which is about 0.9 grams of carbon. Then to work out the mass of hydrogen, the ratio is like 18 grams will give 2. So if we have how much water is there? 1.35. So 1.35 grams, this will be X. Cross multiply, so this will give us the mass of water, which is 0.15. Then to know amount of oxygen, we have to subtract from the total because the total mass is 2.25. So to get oxygen 2.25 minus 0.9 minus 0.15. That will give us the mass of oxygen, which is 1.2. Now we work out the empirical formula, carbon, hydrogen, and oxygen. So carbon, hydrogen, and oxygen, 2.9 grams of carbon, 0.15 grams of hydrogen, and 1.2 grams of oxygen. Divide by atomic mass. So this will be divided by 12, this will be divided by 1, and this will be divided by 16. This will give us the moles for a carbon, 0.075. This will remain 0.15, and this will be 0.075. Then we divide by smallest value in the combination, 0.075. So 1, 2, and 1. So the empirical formula is CH2O. That's the empirical formula. But we need the molecular formula. Molecular formula is empirical formula times N. Empirical formula is CH2O. What is N? N is a molecular mass. In the mass spectrometer, the molecular ion peak is 90. So this is 90. And this is carbon is 12, hydrogen is 16. So this total make 30. So 9. So this will be CH2O multiplied by 30. So C3H6O3. That's a molecular formula. The mass spectrum of a compound T has a peak at 45. Give a displayed formula of two species that could be responsible. So what might, because it's a carboxylic acid with 3 carbon atoms, and there's another functional group as well. C3H6 and O3 is there. So it has 3 oxygens. So there might be OH attached here, or the other group, or maybe ketone is there. 1, 2, 3, 4, 5, 6, 3 carbons, and so what might be the peak at 45? So this is 12 plus 3 makes 15, and this one is 17 plus 12, because two different species we need. And if we count from here, so 16 plus 16, 32, 32 plus 13, so that will be 45. So one of the peak is due to the carboxylic group, C double bonded with O and O and H. And whenever in a mass spectrometer, the peaks are due to the ion. So don't forget to write the charge. So one might be due to carboxylic group. And this is 1, 2, 3, 15, and plus so 15, 16, 16, 32, 32, 12, 44. So this, if you break from here, this will also this might make 45 as well. Why we did not consider as a ketone? Because when I try to make a ketone, it does not match with the molecular formula. Like if I try to make it this as a ketone, 3 oxygen, so then the number of hydrogen are not balanced. That's why we did not take this as a ketone or aldehyde even. The low resolution NMR proton NMR for T has 4 peaks. Draw the structure. Look, the two possible structures. What are the two possible structures? This is one possible structure, that OH might be attached with the first, or OH might be attached with the second carbon. Now first, we have 4 hydrogen environments. Remember, this is always isolated. So one hydrogen environment. This is second hydrogen environment, third hydrogen environment, fourth hydrogen environment. This is first hydrogen environment, second hydrogen environment, third hydrogen environment, and fourth hydrogen environment. So both have 4 hydrogen environment, but when you check, like, because the ratio is 1, 2, 2, 1. The ratio between them is 1 is to 2 is to. Now, if we check which one match with, if because OH can be attached with the last, so this will give a singlet. Like if I say this A, so this will give a singlet, and this will also give a singlet. Here neighbor, and this is the intensity, like relative hydrogen in each environment. So this will be 1, like 1 hydrogen here, 1 hydrogen, 2 and 2. So it will be 1, 2, 2, 1. For this one, it will be 3 hydrogen in one, or it can be, if you start with the end, so 3, 1, 1 and 1. because like one hydrogen here in this environment, one hydrogen here, and here three. But here this will be 1, 2, 2, 1 because one hydrogen in environment, like one hydrogen in this environment, two hydrogen relatively, two hydrogen and relative one hydrogen. So that's why the structure it resemble with this one rather than the OH attached in the second one. In part B, the structure of 2-hydroxy 2-phenyl propanoic acid is shown. Outline how 2-hydroxy 2 can be synthesized in 3 steps, including from a benzene and acyl chloride. Include the reagent in each step and draw the structure of the two intermediates as well. So we start with benzene. We have to add a carbon chain, so it's a Friedel and a Kraft reaction. Whenever we want to add a carbon chain, the Friedel and the Kraft reaction should happen or occur. So first we have to produce an electrophile. So how we can produce electrophile here? So like acyl chloride is there. So we have acyl chloride like CH3C double bonded with ONCl. So we can react with iron 3 chloride FeCl3. So as a result, it will produce CH3C double bonded with O plus and plus FeCl4 with a charge minus. This CH3C double bonded with O will attack, but we don't have to show mechanism. We just have to, we can also use aluminum trichloride or iron. So reagent, we use ethonyl chloride because we have to mention the reagent. So we need ethonyl chloride and aluminum trichloride or iron 3 chloride. So when this is added, we don't have to show the mechanism. So this will be C double bonded with ONCl plus H will be removed from here. It will combine with this iron 3. So it will form HCl plus FeCl3. This will be the first one. The second what we need, because as you can see here, this compound contains 3 carbon atoms, but when we use ethanyl chloride or acyl chloride, we have 2 carbon atoms. So whenever we want to add a carbon chain to a carbonyl group, such as aldehyde or a ketone, we should use hydrogen cyanide. A mixture of HCN and KCN should be used. So this was the first reaction, like first reagent. Now, so this is our first. Now step 2, I'm writing step 2. Step 1 is completed. So what we do, the reagent which we use like hydrogen cyanide and potassium cyanide here. As a result, like say HCN is there. So hydrogen will be added here and nitrile group will be added there. It's same like unit 4 in which carbonyl compounds converted into either the carboxylic acid. So this will form COH will be there and CN will be there and then Cl is all. Not CA, this was CH3, sorry. CH3. Because already this was there, so H and Cn. So we use a mixture of potassium cyanide and hydrogen cyanide in sulfuric acid. and then an alkaline solution is added, like sodium hydroxide is added. Now the last reaction we want to convert this nitrile group, because this is the product what we want. We want we have this we just want to convert this nitrile group into carboxylic. So if you want to convert the nitrile group into carboxylic, so we can use any acid here, like hydrolysis is done. So acid hydrolysis or a base hydrolysis can be done. So the last stage, we were OH, CH3, and then CN was there. And then when we do acid or a base hydrolysis, so nitrile group will convert into carboxylic. COOH will be there. So that is what we want. We want like carboxylic group, like this carboxylic group, this carboxylic, then a carbon attach here, carbon attach here. Next to that is methyl and OH, methyl and OH groups. Usually we use any strong acid. You can use like sulfuric acid. It can be acid hydrolysis or base hydrolysis, which can result in the formation of these ions. Then we have 2-hydroxy 2-phenyl propanoic acid is a biodegradable. We have to draw repeat unit. Look, this is 2-hydroxy propanoic acid is there, and it is forming a polymer. So it will form a condensation polymer when carboxylic acid and alcohol. So one side you remove H and other side you remove OH. So we draw the same structure as we want a polymer. Draw the two repeat units. So one side remove, it's up to you, any side. One side you remove H, other side you remove OH. One side you remove H, the other side you'll remove OH. So if you remove H and OH, we link them together. Don't put a like N there because it's a repeat units. Even bracket is not important when repeat unit. If they say draw the structure of polymer, then only. So you can see here, this will form an ester linkage. This will be the polymer which is formed by these two, like identical. And it's a biodegradable, means it can decompose by itself. So this was the question 6 from organic synthesis.